Hello guys, Dr. Hasbullah here, and in this video we're going to take a look at a phenomena that is called the Mach cone. Okay, previously you have already been introduced to what we call the Mach number. Alright, and Mach number is the ratio between the velocity of the object and the speed of sound. Right, and for Mach number less than 1, we call it subsonic flow. Mach number greater than 1, we call it supersonic flow. And Mach number greater than 3 or Mach number greater than 5, we call it hypersonic flow. Now, let's see the significance of this different Mach number. When I speak, okay, so this wave will originate from my mouth and it will propagate radially. Right? It will propagate in radial direction and it forms a sphere around myself. Okay, and whoever that's in that sphere will hear my voice. Okay, let's say if I make a few beeps, right? Okay, and I'm not moving, right? And I'm still here, right? At t equal to 0, I'm here. And at t equal to 1, I'm here. T equal to 3, I'm also still here. Okay, so what happens to the sound waves? Alright, these sound waves will look something like this. Okay, let's use purple. Okay, so the very first sound wave that I emit, right, is going to travel a lot further, right, a lot further. So probably it's here. Okay, so it could be there. And on a later beep, okay, it could be something here. Okay, so on the third beep, okay, the very recent beep, okay, it could be here. So my voice will travel further and further. So as the time passes by, okay, these lines, okay, let's say these lines will go bigger and bigger. Okay, and if I produce a new sound, then it's going to generate a new wave originating from myself. Okay, so this is what happens at Mach number equal to 0, right? Because I'm not moving at all, so my velocity is 0. Okay, so this is u over c. Of course, you have some value with c, but my position is 0. So this is Mach number equal to 0. Alright, now I'm going to show you something interesting. Okay, let's say I am moving. Okay, but I'm not moving faster than the speed of sound, but I'm moving a little bit slower than the speed of sound. And let's see what happens to the sound waves that I generated. Okay, now let's say at t equal to 0, I'm here. Okay, and then at t equal to 1, let's use blue, I'm here. Okay, and at t equal to 3, let's use green, I'm here. And now my position is here. So now, what do you think the shape of the wave will look like? If you notice, right, for the first wave, which is when I'm here, right, it's gonna look bigger, right? So the size is still big. Okay, so probably it's here. Okay, now at time equal to 2, right, that's the blue line. Okay, and I'm gonna draw it as the blue cross is my center. Okay, so now let's make it bigger. Okay, and to make the blue center, it may be there. Alright, now at time equal to 3, I am now here. Alright, and at time equal to 4 that I haven't produced anything yet, so I haven't beeped yet. Okay, so this is what it looks like for Mach number less than 1. Okay, and if you notice this wave here, the purple wave, okay, the very first wave will always be in front of my position. Okay, this is my current position now, right? And if I'm constantly moving to the right, okay, so let's say I'm moving to the right at speed u equal to 100 meter per second. Okay, but this wave, right, is moving at u equal to maybe 300 meter per second. Okay, this is not u, this is the speed of sound. So obviously, the wave will always be in front of me. Okay, and that might be obvious, but what is the significance of this? Right, it means that if I'm coming and I'm speaking, you would hear my voice first before you see me. Okay, so basically I'm always announcing my arrival. Okay, if you sit somewhere and I'm coming towards you, you will always hear my presence, even though I'm not there yet. Okay, because I'm moving at the speed slower than speed of sound. Okay, and what happens now if I move at Mach number greater than 1? Okay, now this is when things get very interesting. Okay, so let's do purple again to indicate t equal to 0. Okay, so this is t equal to 0, right? And now let's do blue. Alright, and this is t equal to 1 now. The distance will be greater than this case, okay, because now I'm moving much faster, right? And t equal to 3, we're going to use green. Let's keep it consistent with the previous figure. And my position now is here, 4. T equal to 4, right? Now, my sound wave, right, at t equal to 0 is that big. Okay, that big, right? Now my sound wave at t equal to 1, right, looks like this, possibly. Okay, with the blue mark as my center, right? And my sound wave at t equal to 3, let's use green. Okay, sorry. Okay, and it's there. Right? Okay, now, if I continue to move to the right, okay, if I continue to move to the right, right, this wave, right, this wave will never catch me. Okay, why is that? It's just because I'm moving a lot faster than it is, right? This is where I'm at Mach greater than 1. Okay, and what's the difference between Mach greater than 1? What's the difference between this figure and this figure? Okay, now you'll see that when I move a lot faster, okay, the sound is not catching up to me. Okay, and as the result, if I go past you, right, you would see me, but you never hear the sound yet. Okay, after a while you will hear it once the sound wave catches up. Okay, and this is quite interesting for me because if, let's say, a supersonic jet, right, if it flies at Mach number greater than 1 and it goes right in front of you, you would see the jet, but you won't hear anything. Okay, isn't it amazing? Okay, this is quite counterintuitive because usually when we see something, we expect to hear the sound. And if we see an aircraft, we expect to hear the sound. But this time, if it goes towards you, you never hear anything. Alright, so this is the interesting bit about being Mach number greater than 1. Okay, and what happens here is basically if I draw a line, okay, connecting the outer edge of the sound waves, right, and this is supposed to intersect here. Okay, I'm sorry about the scaling. Okay, this is supposed to intersect here, right? Okay, now before we go any further, let me repair the scaling. Okay, I think scaling is a bit all over the place because later we need to draw a line. Okay, let's see if this works. Okay, and the lines that connects the edge of the cone should intersect the source. Okay, should intercept the source. Okay, now obviously I'm gonna remove here and let's say the source is here. Now this is obviously because of the lack of scaling in my diagram, but it should look something like this. Okay, and remember, this is when we represent things in 2-dimensional, but obviously in 3-dimensional, this line would actually form a cone, right? A cone, an ever-expanding cone originating from the source. Okay, and this is what we call the Mach cone, right? The Mach cone, right? And if you study this code a little bit further, this is getting interesting, okay? And if I use the line red here, and I take the line here, okay? And also, I know that because my velocity here is the velocity of this wave will be c, and my velocity moving to the right, now let's use black, okay, is u. So you have the speed of sound in the form of waves, and you have my velocity, which is u. And if you draw this line, okay, let's go back to red, and if you draw this line, okay, and this is at 90 degree, okay, and if you notice this line, if I keep drawing the red line, okay, and this is the blue, okay, so it goes to the blue, okay, and this, the distance for this is c times delta t, right? If you multiply velocity and time, you get the distance, right? So c is the speed of sound times delta t, okay? And in here, because it happens after 2 delta t, so this is c times 2 delta t, alright, and this is c times 2 delta t, okay? And the distance from here to here, okay, let me do now, let's do in black, okay? So this distance, right, is velocity, or this distance is velocity u delta t, isn't it? Because I'm moving at the speed of u and times the delta t, the time for me to take to get there. So if I multiply that, I'll get my distance, right? If you multiply the delta t with the speed of sound, you get the wave distance, okay? Now, and here you have u times 2 delta t, and here you have u times 3 delta t. Okay, and if I take something, now let's use purple, or maybe let's use brown, okay? So here, if I take the angle here, alpha, okay, I can do sine alpha, okay, and this is equal to c delta t divided by u delta t, okay? And of course, delta t is going to cancel out, so alpha is actually the arc sine c over u, right? And what is c over u? So alpha is equal to arc sine 1 over Mach number, okay? So this is very important, because once you know the Mach number, you can find the angle, that is alpha, which is the cone angle. Okay, so alpha is basically the angle of the cone, right? The angle of the Mach cone, meaning that anything outside of this cone is the zone of silence. Okay, if I draw again the cone, it's getting a bit busy. If this is the cone, okay, and this is your alpha, right? So outside the cone, like I'm moving to the right, okay, this is my u. So outside the cone is called the zone of silence, meaning that if you are outside of the cone, you'll never hear anything until the cone catches up to you, right? When you hit the cone, then you will hear the sound, right? Okay, so that's it about the Mach cone. Now, how about we take a look at one example, right? So let's say, okay, let's say this is the ground, okay, and you are standing here, okay, and then there's a supersonic flight that's moving to the right, okay. Imagine that this is the supersonic flight that's moving to the right, and this flight, because it's supersonic, then it will have the Mach cone, okay. And here is what the cone looks like, okay. Okay, so of course it's gonna look something like that. The aircraft is traveling about 200 meters above ground. Okay, the aircraft is traveling about 200 meters above ground, and is traveling at Mach number equal to 3. Alright, and now I have two questions for you. First, what is the velocity of aircraft? And the second question is how far the aircraft can go before you start hearing the sound. Okay, so I want to find this length. Okay, so how far it goes before you can hear the sound. Alright, so now let's try to work on question number 1, which is the velocity of the aircraft. Okay, so let's change to black. Okay, velocity of aircraft is, first let's write the equation. Okay, so Mach number equal to velocity divided by speed of sound, and we know that this is what we are looking for. So U is Mach times C. Mach number is 3 and C is equal to square root K times R times T. Okay, so this is 3. K is specific heat ratio, which is 1.4. R is the gas constant, 287, right? And T is temperature. Okay, we do not know the temperature, but let's assume temperature is 25 degrees C plus 273 because we need it in Kelvin. Okay, and you end up with 1.4 times 287 times 25 plus 273 square root times 3. Okay, so the aircraft velocity is 1038.1 meter per second. Okay, so 1038 meter per second. Okay, let's take some time to reflect the answer. Okay, this is obviously very fast. Now imagine this is about 1 kilometer. Right, so for every second, the aircraft has moved 1 kilometer. Right, so just imagine how cool is that. Okay, how fast is that? Now let's work on question number 2, which is to find L. Right, and we know that if we take alpha here, right, alpha, we know that sine alpha is equal to 1 over Mach number, right? Okay, and also sine alpha from this figure is actually okay, so this is actually sine is 200, so that will be 200 divided by this length, isn't it? This length, and that length is 200 square plus L square square root. Okay, and that is our sine, right? And we know that Mach number is 3. Okay, now this is just a simple mathematical problem. So 1 over 3 is equal to 200 over square root of 200 square plus L square. Alright, now let's solve for this. Alright, so that will be 200 times 3 square minus 200 square and square root. Okay, so L is 565.6 meter. Okay, so L here is 566 meter. Alright, now there you go. That's our answer for both questions. So first, the velocity is more than 1000 meter per second. That's pretty cool. And the second one is that the L, okay, is 566 meters. So it's about 600 meters. So basically, when you see the aircraft in front of you, right, and you won't hear anything until it's over half a kilometer away, right? When it's half a kilometer away, then you hear the sound of the aircraft. Okay, so that is what it means. That is what L equal to 566 means. Alright, so I think that's pretty cool. That's quite unusual because usually we don't get to see it often, but this is compressible flow. After this, you're going to learn a few more concepts, right? That's going to differentiate between compressible and incompressible flow. Okay, there are a lot of more cool things ahead. Okay, so that's it for now. I think the video is a bit longer now, right? So thank you for listening and I'll talk to you soon. Bye.